Okay, that had a horrible effect. Hold on a second, let's back up. Last time, when testing the dyno, the motor would jump back and forth. This was because I was shorting the motor coils together on and off. When they were shorted together, they would build up energy in the motor windings, and when off, that energy would energize the windings briefly, moving the motor in the wrong direction. What I need to do is provide a place for that energy to go when the switches are off. Let's dive a bit deeper into this. Motor windings are coils of wire. In electronics, this is called an inductor. Inductors store energy. In this case, the energy comes from the rotating magnets called the rotor. To control the flow of energy, we need two things: one-way valves, called diodes, and some special switches called MOSFETs. MOSFETs have a funny looking symbol, but they're really just a switch and a diode in parallel. So when closed, they act like a wire, and when open, they act like a one-way valve. Here's the new circuit I'm building. When the switches are closed, the energy builds up in the motor windings, and when they are open, it flows into the resistors where it's converted to heat. In a regen braking system, it would be used to charge a battery instead. Unfortunately, things are not so simple. When you open and close switches, they bounce. When we are dealing with MOSFETs, we call this type of bouncing ringing. When this occurs, the voltage can shoot extremely high, and if your circuit is not designed properly, it'll break things. Well, let's go back to the dyno setup and take a look how it's supposed to work, and then we'll look at what went wrong. All right, so here's the setup this week. We added an exhaust fan. The dyno, the motor, and the electric motor are set up the same. I've got a different H bridge. This time, actually, it's essentially a full H bridge. I've got a resistor to dissipate the heat. We've got the same control board as before. I've added a slightly larger monitor. The refresh rate's a little bit too fast, but it's all right. I'll get the idea. And then I've got an oscilloscope down here, just showing the PWM on the gate and the drain source voltage on the MOSFETs, and I'm expecting to see some heavy ringing. So, just about ready to turn it on. This is the exact moment everything broke. All right, so test last night, definitely fried some MOSFETs, and there were some huge spikes, huge ringing from the MOSFETs. Not unexpected, didn't know they'd be so high at very, very low RPM. But so this setup without something to mitigate those spikes is not gonna work. So the diodes seem fine. And I don't know about the gate drivers, but at the very least, I'm gonna have to replace the MOSFETs. Another big mistake is that there was no isolation between the microcontroller board and this board. So when the MOSFETs failed, it blew up the microcontroller board. So for today's test, I'm just gonna use an Arduino, and I don't care if it blows up. So there's two things I can do. One is to slow down the turn on time of the MOSFETs by increasing the gate resistors. And then the other one is a snubber network, but I don't know that I have any suitable parts to make a functional snubber network. So now I'll take off some heat sinks, try and replace these MOSFETs. Cue the music.
Circuits humming in the factory. The machines are drumming, soldier sparks fly, creating a symphony to the beat of the assembly line's melody.
I don't know if it works for sure, but we'll try. But I think I'm gonna get some capacitors and just 1 ohm resistors. So I'm gonna run out and then be back. Anyhow, 我找这个电容。谢谢啊。你好，大一点的电阻有现货吗？
Tôi chào ạ.
Synchronized movements, precision in the air, creating a techno symphony.
Cha-cha. Okay, we're good to go.
To fix ringing, you need a circuit to smooth the high voltage spikes. This type of circuit is called a snubber network and can be built out of a resistor and a capacitor. Ideally, you know the parameters of the system you're trying to modify and can calculate the correct values. I took another approach, pure guess. Let's see if it works.
All right, test number 2, 600 volt MOSFETs, some kind of snubber circuit, and 20% PWM. So let's see how this goes. Okay, well that's a result. That's definitely a better place to end for the day. So the resistor is getting nice and warm, so there's definitely energy being captured. The MOSFETs didn't blow up. There's still some ringing, but at least now I can measure the frequency and design a better snubber circuit, and definitely some opto-isolation between the microcontroller and the MOSFET board. But overall, successful. Another step. I'll analyze, regroup, and be back with more changes next time. Thanks for watching. Bye-bye.